Hey team, today we're going over rational expressions involving complex fractions. So first of all, let's start with what a complex fraction is, and we'll do a couple examples with them. So complex fraction, it's a rational expression that has at least one fraction in its numerator, denominator, or both. So here's the first example we're going to go over. We'll start with a more basic one, and then the second one will be a little more challenging. And so here we have a 1 over x plus x over y divided by the quantity of 1 over y plus x. Okay, how in the world could we simplify this rational expression? Well, for starters, we have a big fraction bar, so I'm going to rewrite the whole entire thing as 1 over x plus x over y. And instead of writing a fraction bar, I'm going to write the division sign. And then we'll have 1 over y plus x. So it looks a little more tolerable now, something a little more familiar. And now I have two separate problems. I have an addition problem on the left side of my division sign, and I have an addition problem on the right side. So I'm going to take this left side, start here, and I'm going to simplify just this left side. And in order to add fractions, I need common denominator. So it looks like on the left fraction, I'm missing the variable y. So I'm going to multiply the top and the bottom by y. Over here, I'm missing the variable x in the denominator, so I'm going to multiply the top and the bottom by an x. That will give us 1y plus x squared divided by, looks like we have x times y, and that just made a triangle for me. Let me undo that. Let's try it now. So x times y underneath. Cool, that is our common denominator. And right now that is being divided by 1 over y plus x. Well, we have to do the same thing over here. Right now this has a y in the denominator. This doesn't have anything in the denominator except for number 1. So let's multiply this side by y over y. So now we'll have y squared, y plus x squared over x times y divided by 1 plus x times y all over, looks like the common denominator here is y. So now we have both sides. We can't really factor anything, multiply anything else together. So I'm going to multiply by the reciprocal. Instead of dividing and doing long division or synthetic division, we're going to multiply by the reciprocal. So we have y plus x squared over x times y multiplied by y over 1 plus xy. Much better. Okay, and so we're very, very close to having this being completely simplified. At this point in time, before you cancel anything from the numerator and denominator, we have to point out what our restrictions would be. So the restrictions are, well, we can't divide by 0, because we get errors like a 1 equaling to 2 or a 0 equaling to 1, something like that, if you divide it by 0. So let's see. It looks like the quantity x times y cannot equal a 0. So together, they cannot equal a 0 when they're multiplying, so either an x can't be a 0 or y can't be a 0. And over here, it looks like 1 plus x times y, well, 1 minus a 1 would be 0. So it looks like x times y, the product of x times y, cannot equal a negative 1. Okay? And so it depends which, any combination could give you a negative 1, depends, but the product of those two numbers cannot give you a negative 1, otherwise we'll be dividing by 0 in this problem. So those will be our restrictions. Now let's see, what can we eliminate, what can we cancel? Not a lot. Looks like the only thing going away would be the y here and the y here. And technically it couldn't be this y because this is in parentheses, it's adding to the x squared. This would be multiplying that, so y times all that. You could divide that out. Technically all of this is in parentheses as well. So it looks like nothing else could cancel out, leaving you with y plus x squared in your numerator. And we'd have x times 1 plus xy in your denominator. That would be simplified form. Alright, so this one we're going to step it up a notch in this example. Let's say we had x minus 2 over x plus 2 over x plus 1, all divided by 3 over x minus 1 minus 1 over x plus 1. Okay, so this will be our problem, and it looks pretty complex. Yeah, this indeed is a complex fraction, and let's just break it up. The first thing, I see this giant fraction bar. Let's go ahead and rewrite this. So we'd actually rewrite it as x minus 2 over x plus 2 over x plus 1 divided by, I'll give myself a little space there, divided by 3 over x minus 1 minus 1 over x plus 1. Okay, that makes it look a little more tolerable. It's we don't have 4 layers here, it's just 2 layers. Okay, and technically these are in parentheses. If you wish to write them in parentheses, I will. So let's start with the left side. So left side of this division symbol, in order to add these fractions, we have to get common denominators, same thing as before. And so it looks like the left side has an x, but it doesn't have x plus 1. The right side has an x plus 1, but it does not have an x. So we're going to multiply this fraction by an x plus 1 in the numerator and the denominator. And over here we'll multiply this fraction by an x on the top and the bottom, just like that. And look at that, we have common denominators. X times x plus 1 would be that common denominator. On the top, we have x plus 1 times x minus 2 plus 2 times x. And underneath in the denominator, we just have x times x plus 1. Okay, more on that in a second. Let's get the right side. And so we have an x minus 1 on the left and x plus 1 on the right. Well, in order to get common denominators, I need to multiply this side by an x plus 1 in the top and on the bottom. And over here I need to multiply by an x minus 1, numerator and denominator. Okay, that would leave you with a 3x plus 3. So divided by 3x plus 3. And don't forget about this negative sign. Technically this would be a negative 1. So negative 1 times x will give you a negative x. Negative 1 times a negative 1 would give you a positive 1. And all of that would be over x plus 1 and x minus 1. Okay. And so on this top right, looks like we can do a couple things. We could combine our like terms. So let's go ahead and do that. So 3x minus x would give you a 2x, and a 3 plus a 1 would give you a 4. Okay, that might help us out. And still underneath we have an x plus 1 and an x minus 1. Up here in the top left, let's go ahead, and there's not a lot I can do right now. Let's go ahead and multiply these together. So let's FOIL this. So x times x would give you x squared. X times a negative 2 would give you negative 2x. I'm missing my number 1. There we go. And then 1 times x would give you a positive 1x. And 1 times a negative 2 is a negative 2. And then don't forget about this positive 2x right here. It's still a part of the problem. And so when we're simplifying this, we end up with, well, negative 2x cancels with a positive 2x. So you're actually left with x squared plus x minus 2, all over x times x plus 1. Okay, so now this is what we're dividing. We have x squared plus x minus 2 over x times x plus 1 divided by all of this. Okay, at this point, let's go ahead and multiply by our reciprocal. So multiplying by the reciprocal, we need to, well, first of all, I will flip this fraction, but I'm going to see if I can factor this up here, because I have x squared plus x minus 2. Well, what multiplies to a negative 2 and adds up to a positive 1? I'm thinking a positive 2 and a negative 1 would do the trick. Yeah, because that together adds up to a positive 1, multiplies to a negative 2. Hey, that's factorable. And that is all over the quantity of x times x plus 1. Now we're multiplying by the reciprocal, so that is now a multiplying sign. And we have x plus 1 times x minus 1 in the numerator. And we'd have 2x plus 4 in the denominator. I'm going to factor out a 2 right now. So I can take a 2 out of this term, I can take a 2 out of this term. So that'd be 2, leaving me with x plus 2 in parentheses. Okay, and so we always look for GCFs, you always look for things you can factor. GCFs and factors when you have these type of problems, and when we have rational expressions. Okay, before we cancel anything before we cancel any terms out, at this point, let's look for any restrictions. So the restrictions would be whatever makes the denominator 0. We don't want to multiply, or we don't want to divide by a 0. So it looks like, right now, the restrictions, we have a couple of them. Right now, x is multiplying by everything else, so x can't be a 0. Looks like negative 1 plus 1 to be a 0, so x can't be a negative 1. And here, negative 2 plus 2 would be a 0, so x cannot equal a negative 2. And I don't see anything else, so those will be our 3 restrictions this time. So x could be anything in the domain except for those 3 numbers. Now we're going to see what we can cancel. It looks like we have an x plus 2 in common with an x plus 2 over here. And yes, we can reach from the way in the bottom right to the top left because we are multiplying these two fractions, so they are able to be canceled. And we have an x plus 1 here and an x plus 1 here. Those would cancel as well, leaving you with x minus 1 times x minus 1. Well, that's just x minus 1 squared over 2 times x, 2x. And that would be your simplified version for our expression. There you go. And if you pull up a graph here, so here, give me a second, type this into Desmos. If we pull up a graph here, looks like the original expression gave us this graph. If we have our simplified expression, you notice it's the same graph. And when we're in the middle of our work, hey, check it out, the same graph. And so a nice little check that we did things correctly, and that's pretty neat. And again, this would show your restrictions as well. X can't equal those three numbers we talked about, 0, a -1, or a -2. Alright.